In this video, we solve an important problem related to discrete time signals, where we use difference equations to find the frequency response and the impulse response of an LTI system. In this problem, the difference equation of a discrete time LTI system is given. In part A, we are asked to find the frequency response of the system. To do this, we first need to review a few key points. The first point is that for an LTI system, the Fourier transform of the output is equal to the frequency response multiplied by the Fourier transform of the input. Therefore, the frequency response of an LTI system is equal to the Fourier transform of the output divided by the Fourier transform of the input. The second point is that if a signal Zn has the Fourier transform z e to the power j omega, then the signal z n minus n0 has the Fourier transform e to the power minus j omega n0 multiplied by z e to the power j omega. The third point, which we have mentioned many times in previous videos, is that the Fourier transform of a to the power n multiplied by un is equal to 1 divided by 1 minus a e to the power minus j omega. Now we move on to solving the problem and finding the frequency response of this LTI system. We first take the Fourier transform of the given difference equation. The Fourier transform of xn becomes x e to the power j omega, and the Fourier transform of yn becomes y e to the power j omega. For the term yn minus 1 using the time shifting property with n0 equal to 1, the Fourier transform becomes minus 1/6 e to the power minus j omega multiplied by y e to the power j omega. Similarly, for yn minus 2, where n0 equal to, the Fourier transform becomes minus 1/6 e to the power minus j2 omega multiplied by y e to the power j omega. Now we factor y e to the power j omega from the left hand side, and we already have x e to the power j omega on the right hand side. By dividing y e to the power j omega by x e to the power j omega, we finally obtain the frequency response h e to the power j omega as given by the resulting expression. In the next part, we are asked to find Hn, which is the impulse response of the system. Since we already know the frequency response from the previous part, we can find Hn by taking the inverse Fourier transform of h e to the power j omega. To do this, we first decompose the frequency response into simpler fractions. We treat the denominator as a second-order expression written as the product of two first-order terms. From this, we determine the corresponding coefficients where one term involves minus y half e to the power minus j omega and the other involves 1/3 e to the power minus j omega. Using partial fraction decomposition, we rewrite h e to the power j omega as the sum of two simpler fractions. To find the coefficients, we multiply h e to the power j omega by each denominator in turn and substitute the corresponding root of the denominator. By doing this, we obtain the coefficients 3/5 and 2/5 respectively. Now we can easily compute the impulse response using the known Fourier transform pair. The first term corresponds to 3/5 multiplied by 1/2 to the power n multiplied by un. The second term corresponds to 2/5 multiplied by minus 1/3 to the power n multiplied by un. Therefore, the impulse response Hn is given by the sum of these two terms. In this video, we solved the complete example involving difference equations in discrete time LTI systems. If you found this problem useful, you can check out the other related videos on this channel as well.